alert around Greeley area, but high wind advisory today. Yesterday it was a fire kind of watch out fire kind of thing, but not today.
Yeah, it was it was it's just I don't know, like it feels like it's been much windier this spring than usual. We've had many more high wind days. So
Yes.
I don't know. It's Colorado. It's supposed to be windy.
Well, good afternoon, everyone, and welcome to The Reason I Didn't Like Math Before is Because I Never Felt Creative, Fostering Creativity and Calculus. Our presenter today is Gulden Karakok. I think I said that right, correct me if I didn't, from the University of Northern Colorado. And if you have any questions for our presenter during this session, please feel free to use the chat box below, and we will cover it towards the end of the talk. So on that note, I will hand it over.
Thank you, Kelsey. Thank you, everyone, for being here at this Saturday at noon hour in the Mountain Time. Today, I'm going to share a little bit about research work that I do with my research group. But first, I want to acknowledge yesterday was the Earth Day, and today is the International Children's Day. So those 2 days together, I think goes really well with the work that I've been doing on creativity in mathematics. So I'm going to kind of touch on those ideas a little bit. So thank you for being here. All right, let's see if I can figure out my slides. All right, so the title of my talk, the reason why I didn't like math before is because I never felt creative. This is something Calculus 1 students said when we were doing interviews with them after they completed Calculus course using some materials from our research work, and the instructors were implementing some ideas from our research work. And in the chat box, I'm going to put our research group's website so you can see what we're up to. We're trying to update it as much as possible. And my name is Gulden Karakok. I'm from University of Northern Colorado in the math department. And my colleagues in the research group, we are all around the country, so working together on these different aspects of creativity, focusing on different areas. And these are the current research members actively working on research projects. And we do have other researchers come and go in our research groups, and everyone is welcome. If you're interested in joining us, just send us an email. And let me put that links here. Let me see. I'm putting a bunch of links in the chat box, so I will touch on those things as we talk. And the first one is the Creativity Research Group's website. All right, so the second link you're going to see is Sir Ken Robinson talk about do schools kill creativity? And then the second one is a YouTube video talking about our mathematicians creative. So these talks actually kind of oldish, I guess. They're 2006, 2010. So our research group kind of started working on this topic, mathematical creativity, in 2012. And since then, we have been looking at different ideas in mathematics undergraduate level, mathematics courses, and focusing on how can we enhance undergraduate students' mathematical creativity. And those talks actually inspired our work throughout our research projects. Currently, we're finishing up our NSF projects on reshaping mathematical identity by valuing creativity in Calculus 1 courses. And new projects are coming up. So if you're interested in participating in any of our projects or upcoming projects, please send us an email. We're happy to share what we have. So I want us to reflect quickly. So if you have a piece of paper somewhere, or if you can take some notes on your own somewhere, that would be lovely. So the very first question that I want you to reflect is, think of a creative person. Who are they? Right? What comes to your mind when you hear the word creative person? All right. Second question I have for you, are you creative? I'm going to tell you the answer. Yes, you are. So I'm going to skip this question. The third question, think of a creative student. Who are they? Now I'm going to jump into these ideas that when you heard these questions, I'm curious, how did you decide? What were your criteria? Was it a product that they produced, or was it their thinking process that made them creative for you? So those are the kind of things, and I'm going to open it up to the whole audience. I just want you to chime in and say stuff, whatever you thought about any of those things. We're a small group, so you can jump in and tell us what you're thinking.
I'll start so nobody else has to. I thought of my friend Julie, who is a math teacher, and she's very creative in bringing in hands-on ideas in the classroom.
Thank you, Beth.
I'll add something. I was actually thinking about a student who has such an amazing math intuition. I was his teacher, or his professor for, proofs and upwards. And in the beginning, I was so shocked by his new ideas. I was like, no, this doesn't work. I haven't seen it ever. You aren't inventing new stuff. And by the second year, I was like, no, actually, I believe it. You have an amazing intuition. Now, I'm not sure that intuition and creativity is the same, but I think he had both.
Awesome. Thank you, Mona. Let's hear from one more person.
I'll say something if that's
Thank you,
okay.
Jenny. Of course.
My answer to your last question is, was it their process or a product? And my answer is yes, both. There are people I think of as being creative because they produce beautiful things. I am very struck by mathematicians that create art. So there are many people I think of like, even people like Laura Talbin and all of her 3D printing, I think is very creative. I think of Frank Ferris and his artwork that he's creating. I love Colin Adams and all of his crazy plays that he puts on, right? But then when you asked about students, and the students I think of as creative, they're the ones who ask the questions that are really probing, that are trying to get at the deeper truths. And I find that kind of creativity really exciting.
Absolutely. Thank you. Thank you all for sharing these ideas. And you're capturing all these different aspects of our work in research and creativity. And I'm going to touch on these ideas you shared as we are going. So quickly, I'm going to show you the results of our project first, because I know I may not have enough time at the end. But we're going to talk about the motivation. Why should we care about creativity in our math courses? And then like some of definitions and perspectives in creativity. Just like any math research, in math education research, we have to figure out our definitions. We have to figure out the properties of our research construct. How do they interact with other things? So I'm going to talk about those ideas too, and some of the things that we do in our research projects. So the very first results that we have since 2013, we created this creativity in progress reflection tool. And this tool has two components: making connections and taking risks. And it is created for both the teachers and the students. So in these tools, like as a teacher, you can give students some problems or some proof question and have them kind of do their proofs or problem solving and have them evaluate themselves and their solution process as well as proving process, and thinking about these different aspects. Are they at the beginning level for themselves, or do they think that they're advancing in different parts of it? And then so they can think about how they can improve themselves as the course goes on further along in the semester. And as I said, there is like an interesting thing that in my opinion we put not applicable, and the arrow indicates that it's not like you're beginning at like 0, 1, 2 kind of a scale. It's kind of continuous scale like that. And then the other thing that we did, we gave these rubrics, both the teachers and students in the classroom, on their proving or problem solving courses, and have them be kind of thinking about their thinking, kind of be metacognitive about their aspect. This is from one of my students in my problem solving class, that at the end of semester, they had a reflection to write about what happened in that class, that they were talking about this completing and evaluating myself on the creativity and progress reflection rubric was another area that solidified this idea for me that creativity is part of mathematics. And then the other thing that we have been creating is these tasks, particularly for calculus courses. For example, this is one task that we give our Calculus 1 instructors to implement in their classroom in whatever way they want. They can put it on a discussion board. They can have it as part of their recitation sessions for discussions, or it could be part of an homework assignment that students write about, or on an exam question for completion kind of a thing. Is there a perfect circle in real life? And how do you know if you have a perfect circle? And we had gotten really interesting ideas from students where they actually connect mathematics to other arts and other areas of their life from other courses. So we have different tasks actually for Calculus 1, and we try to develop more. If you have more ideas, we're happy to have them. So let's have the story begin. So in our story, we had this big discussion with our research group colleagues. We were kind of wondering, can you teach creativity in mathematics? And we realized, well, I don't know. So the idea, like, what does it mean to teach creativity? If you teach creativity, then is it creativity? So a bunch of these different ideas came up, and we know that students are very, very creative, and how can we showcase their creativity to themselves in mathematics? So the question is, how can we explicitly value and enhance students' mathematical creativity at the post-secondary level? And what are those pedagogical actions we can take and do to highlight these ideas to the students and to ourselves as well? And I want to highlight yesterday at Jenny's talk, she was talking about the contest that, yeah, she had this process of posing a problem and answering it in 2 different ways. So this is one of the ideas that we talk about in our professional developments with instructors. It's a one way to get our students think about or improve their creativity, is posing a question and answering it in multiple ways. So that's one thing that we noticed in our research. Why do we care about creativity? We care about creativity because workforce out there, they talk about how it's important for our future generation getting these jobs to be creative. It's more than just memorizing, it's just more than knowing facts or ideas, but being creative and using those skills out there. And recently, I say recently, but this is 2015 or maybe 2017, the World Economic Forum, they actually provide list of skills that the future generation should develop. And then creativity actually became number 3 in recent years. And then problem solving is, of course, right there, but the creativity is one thing that they mentioned that it should be there. And then Mathematical Association of America's Committee on Undergraduate Programs, they have the guidelines for mathematical sciences, and they highlight the creativity, importance of creativity, encouraging students' creativity. Of course, doing that through getting students curious about mathematics. And then, of course, these are people out there telling us what we should do with our students, but how about our students? What do they say about mathematical creativity? So I'm going to share one student idea from 2016. This student was in an introduction to proofs course, and we were implementing the creativity in progress reflection tool in the course. The instructor, we were talking about creativity in the course, and this is what the student says. It is shocking to me that the creativity involved in math is often overlooked. A professor at my school is dedicated to integrating creativity in her coursework to ensure students are engaged and excited throughout the entire course. It was in her course that my interest in the topics of number theory grew. So this student, after taking this course, changed her major actually to mathematics. And on top of it, she applied for REU program for the summer. And here's another student after doing Calculus 1 in spring 2020 with the instructor who was implementing our materials in the course. And this is what he says. Most creative I felt was when I did the C++ homework to do my homework in calculus. It felt nice to just do a different way and approach from a completely different angle. It was cool for me to figure out something out finally on my own. It is one thing that really turns me off about math. It's like, damn, I'm learning about like just something some smart dude said. And then I don't understand how we got to this point. I'm just spitting out whatever he said. I don't know why. So this student actually were given a homework problem of using our creativity task and then decided to do his computer science background to solve the problem with C++ programming. So other research studies actually talks about how emphasizing creativity improves students' self-confidence and promotes anti-deficit perspectives and change students' positionality as mathematicians, that they start seeing themselves as mathematicians. And I briefly mentioned that our initial studies that started in 2013, we looked into what mathematicians thought about creativity and how they used it in creativity videos, and interviewing a bunch of research mathematicians and ask them questions about it. How can we do this in undergraduate math courses? And then that, of course, brings us to the idea that I put out there in math education research. Definitions are extremely important, just like mathematics. So we wanted to know, what is the definition of mathematical creativity? So we went into the research and looked at it. That wasn't that easy. There are more than 100 definitions of creativity, mathematical creativity, by the way. So there are different aspects, and this research has been started in 1902 with surveys to mathematicians asking about what they thought creative in their work. And then one dominant idea is used out there is to look at this 4-stage model: preparation, you prepare and look at the problems, and you take time off, incubation period, and all of a sudden something comes to you for the solution, and then you verify it. Now, when we think about this example, as I think Andrew Weil's quote on this one is great. He talks about, perhaps I could best describe my experience doing mathematics in terms of entering a dark mansion. One goes into the first room, it's dark, completely dark. One stumbles around bumping into furniture, and gradually you learn where each piece of furniture is. And finally, after 6 months, incubation period, 6 months, and then you finally find the light switch and you turn it on, everything is illuminated. So this is kind of an interesting approach to think about, but the issue here is it's not clear that mathematical creativity of students will always occur in a process similar to those 4 stages. So we need to be thinking about this carefully, how we can highlight students' mathematical creativity. So like the difference is, there is the absolute creativity that people talk about, but there is the relative creativity. I think some of you mentioned this, that our students have intuition, insights, and then how can we bring those out there for students to see? So our research group actually focuses on that approach. So our operational definition is, we are focusing on the things that students do, the processes that students take, and that is process-oriented, very dynamic, changes from task to task, course to course, and it develops over time, and it's relative to the students. And then it's very, like, we focus on domain specific to mathematics. Of course, that doesn't mean students only use mathematical tools. They can bring in other tools from other areas. All right, so I think I'm running out of time, if I am seeing that correctly. I'm just gonna jump into, let me stop right here. So you have our research QR code. Feel free to jump there and see what we are up to in the Calculus 1, finishing up that project. So the instructors of this calculus courses that we worked with implemented creativity fostering tasks, just like that perfect circle task, use the CPR tool as a formative assessment tool for their students to reflect on. And then we collected survey from students, interviewed the students and instructors. And we do see a trend that students in our experimental group who are involved in talking about creativity do think themselves as more creative. So now our next stage is to do this work with department level calculus courses and think about how we can focus on different versions of calculus out there. So if you're interested in participating in this research, send me an email.
Thank you so much. That was super helpful. I posted the links for the next sessions. The next one starts in 5 minutes. And of course, you can always access the conference website or the virtual bookshelf. But thank you all so much for your time. And thank you all for sharing your insight. And we will see you in the next session.